Alrighty, boys and girls. So here we are. We are going to start a new chapter. The textbook is section 6.1, and they cover it in one section. We're going to cover it in about 2 weeks. We're going to take our time, make sure we really understand this. And your assignments, since we are covering one section over 2 weeks, are not going to be in the textbook. So I'll explain a little bit more when you're in person if there's any questions, but you should be able to figure it out. So here we go, section 6.1. Multiply monomials. So, first off, let's talk about the vocabulary. Multiply, obviously. Monomials. What's a monomial? A monomial, mono means single term, but it's a little bit more complicated than that. So, this is a binomial. It has two pieces, all right? This is a trinomial, 3 pieces. Anytime you see a plus or a minus, it separates it into parts or pieces. So a monomial, make sure you're writing this down. All of these are monomials. They have one term, okay? They can have many parts or factors, okay? But it's one term. There's no plus or minus in the middle of the problem. All right, this is a binomial, this is a trinomial, these are monomials. So everything we're going to be doing in this section is going to be doing a lot of things with monomials. So today we're going to multiply monomials. So this rule is simple. If you multiply like bases, so if the bases are the same, then you add the exponents together. That's the simple rule. Again, make sure you're writing this down. But that's the simple rule for multiplying monomials. So what does that look like? Well, x to the fourth times x to the third. The bases are the same. Add the exponents. So the answer here is x to the 7th. That's it. So why does that work like this? Well, let's look at this a little bit more in depth. What does x to the 4th mean? It means x to the 4th. There's 4 x's. Okay. What does x to the 3rd mean? There's 3 x's. Well, if I look at this, this is all just multiplication. So what I have here is 7 x's that have been multiplied all together. So that's how this little shortcut works. It allows us to just simply add the exponents together. Okay. Do this one on your own. Very good. Pretty simple. Now, we can spice it up a little bit. With something like this. So we have x to the 3rd, y to the 2nd, times x to the 4th, y. All right? Again, the rule is for like bases. So when we do something like this, we just simply look at the x terms together. So x to the 3rd, x to the 4th is x to the 7th, y to the 2nd, y to the what? What is the exponent here? Well, if you don't see something, what is it? Yeah, it's a 1. So if you don't see a number, if you don't see an exponent, it's a 1. So this would be y to the 3rd. All right. So let's look at a couple more. Do this one on your own. So, again, if I don't see anything, you got to remember, each one of these has its own exponent. The A is to the first power. The 3 is only on the B. It doesn't like extend past there. The C is to the first power. Each variable has its own exponent. So this would be A to the 4th, B to the 5th, C to the 5th. All right. So far, everything we've done has only been variables. We can also throw coefficients in front. Now, it's extremely important. You're going to hear me say this 1,000 times across this lesson. It is extremely important that you remember exponents and coefficients. Exponents and coefficients. Very different things, and they follow very different rules. Coefficients, you've seen coefficients 1,000 times in your life, okay? What's 5 times 3? The new thing is the exponent. It follows a different set of rules. So when you see multiplication with the coefficients, you do the operation that you see in the problem. 5 times 3 is 15. Because it's a multiplication problem. Remember, at its heart, this is a multiplication problem. The shortcut trick is to add exponents if it's a multiplication problem. These are multiplication problems. I can't say that enough. I can't stress it enough. If you're finding that you're doing the same operation on coefficients and exponents, you're doing it wrong. They're very different numbers. They follow very different set of rules. So, try and do this one. What's that going to be? Multiply your coefficients, add your exponents. Very different things follow very different set of rules. Remember, multiply means multiply. This is a shortcut trick, so I don't have to write out all those variables. All right, so it's a multiplication problem. I'm multiplying monomials together. Each one of these is a monomial. That's the rule. Multiply means multiply. Focus on those coefficients. Multiply them. It's a multiplication problem. -2 times 3 times 5. I multiply that together, I get -30. Then, go through and find like bases, things that are the same. X to the third, X. What's the exponent here? 1. What's the exponent here? 1. 3, 4, 5 gives me X to the 5th. Then find your Y's. Y to the first, Y to the 4th, Y to the 1st. 4, 5, 6, Y to the 6th. Are there any other Z's? Nope, there's just this one here. It's 1 Z, so it's Z to the 1st. You don't have to write the 1st. So, take your time, ask questions, send me screenshots on Hangouts. That's the best way to ask questions. So let's get back to the homework. For your homework, it is going to be a PDF that's going to show up. We're not using Google Forms for this chapter. What you're going to do is you're going to write your answers on a separate sheet of paper, take a picture of it, attach it to the assignment, and turn it in. All right? So if you want to print out, if you have print capabilities at home, you want to print it out, that's fine. You can. You don't have to. I just need a sheet of paper with your answers on it. Take a picture of that and send it in to me. All right? So that is how you're going to be completing your assignments for this chapter. If you have any questions, let me know. Other than that, good luck.